Hello, this is a small segment on distinguishing between proportions and means in statistics problems by Silvana Vester. Now, in general, to distinguish between proportions and mean problems, what you need to do is just read the problem carefully and really think about what you would write down on a piece of paper if you were the person asking the subject a question or if you were the person measuring something. Now, it turns out that if what you would write down on your paper is yes or no, then the problem is a proportions problem. And if what you would write down on your piece of paper is a number, then it's a means problem. So what we're going to do is go through several examples and talk through them. Okay, in example 1, in 2001, one county reported that among 3,132 white women who had babies, 94 were multiple births. There were also 20 multiple births to 606 black women. Does this indicate any racial difference in the likelihood of multiple births? Well, if I were the researcher interested in tracking multiple births, eventually I would either ask the individual women, did you have a multiple birth or not? Or I would check their records, but in general what I would write down on a piece of paper is yes or no. So this is a proportions problem. Example 2. The quality control department at a bakery monitors the loaves of bread baked by taking loaves at random as they come from the production line and weighing them. They want to find out if the mean weight is different from 16 ounces. So if I were at this bakery and I wanted to know about this, what I would do is I would literally pick up a loaf as it was coming off the line, and I would set it on a scale, weigh it, and what I would write down on my piece of paper is a number that represents the weight in ounces. So this is a means problem. Example 3. A random sample of pet owners is taken, and they are asked if they include their name or the name of their pet on Christmas cards. We are interested in estimating the percent of pet owners that include their pet's name. Now again, if I wanted to know about this, I would ask pet owners, do you include the name of your pet on a Christmas card? And what I would write down on a piece of paper is yes or no. So this is a proportions problem. Example 4. 2 procedures for packing china in shipping containers were compared in the following manner. Each of the 20 packers was selected and timed to pack one box using each of 2 procedures. The objective of the experiment is to determine whether one method is faster than the other. Now, at first glance, this might seem like a yes or no, like one is faster than the other, but really if think about logistically how we would go about tracking this, I would watch the packer pack and I would time them, and when they're done packing, I would write down a number representing how long it took for them to pack the particular container. So this is a means problem because I would write a number down, and eventually what I would do is take all the numbers, average them, and find the average that it takes to pack in one way and the average that it takes to pack in another way, and then compare those 2 numbers and be able to decide from there which one is, faster. So this is a means problem. Example 5. It is widely believed that regular mammogram screening may detect breast cancer early, resulting in fewer deaths from that disease. One study that investigated this issue over a period of 18 years was published during the 1970s. Among the 30,565 women who had never had mammograms, 196 died of breast cancer, while only 153 of the 30,131 who had undergone screening died of breast cancer. Do these results suggest that mammograms may be an effective screening tool to reduce breast cancer results? Well, if I wanted to know the answer to this question, depending on how this was done, perhaps they would ask the women while they were still alive, do you have regular mammogram screenings? And the answer to that question would be yes or no, and that's what I'd write down on my piece of paper. So this is a proportions problem. It's also possible that posthumously, after the women passed away, files would be checked and seen if they had had mammograms screenings or not. But in either case, yes or no would be written down on your piece of paper. It's a proportions problem. Example 6. The U.S. Army needs to estimate how much water a soldier drinks per day in a desert environment so that the U.S. Army can supply soldiers with an adequate amount of quality water. Take a moment See what you think this is. Do you think this is, you would write down yes or no, or would you write down a number? So if what we want to know is how much water, quality water somebody needs to drink, in the end we would count how many glasses of water or ounces of water per day, and we would write down a number. So this is a means problem. The last example, example 7. Advances in medical care, such as prenatal ultrasound examination, now make it possible to determine the child's sex early in a pregnancy. Because some cultures value the male children more highly than female children, there's a fear that some parents may not carry pregnancies of girls to term. A study in Punjab, India, I'll skip where it came from, reports that in 1993 in one hospital, 56.9% of the 550 live births that year were boys. It's a medical fact that male babies are slightly more common than female babies. The authors report a baseline for this region of 51.7% male live births. Is the sample proportion of 56.9% evidence of a higher proportion of male births? So again, if I wanted to track this, what I would determine is whether the pregnancy that was carried to term was male or female. And if I wanted to know basically if it's more common that there's a higher proportion of male births, I would actually be writing down yes or no, is this a male or not? So this would be a proportions problem. Now, if you notice also, of course, this is the thought process about how you really determine the problem. Usually within the problems, you'll actually see the words proportion, percent, of course when you're dealing with a proportions problem, and you'll see mean or average oftentimes when you're dealing with a numerical problem. Well, thank you very much.